Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic, completing proofs of theorems involving sides of a parallelogram. So, use the given information and complete the proof of the following theorem. So, if a quadrilateral is a parallelogram, then its opposite sides are congruent. Okay, so we're probably going to need that in here, because it starts off telling us it is a parallelogram. So, this one is not a full proof, it's just kind of filling in the missing pieces. So it's kind of helping you visualize how you should approach this one. There's a lot of different orders you could do, so this will help guide you. End goal, I want to prove that QT is congruent to RS. Okay, so that's what I'm trying to go from there. Alrighty, so where did I start here? So I have a parallelogram. So because it's a parallelogram, that means opposite sides have to be parallel. So QR, line segment QR is going to be parallel to line segment TS. And also from the definition of a parallelogram, QT and RS have to be parallel as well. Alright, moving along. If lines are parallel, so I'm going to use these logic statements that I just put in. I'm looking for alternate interior angles are congruent. So 1 would be an alternate interior angle with 4, and 2 would go with 3. So there's my Z there, and then 2 and 3, I'm looking at the side ones. So if I know that, then I need to prove that 2 looks like line segments are congruent. So what am I going to get there? Alright, well, I think the only thing I can say for sure is RT, since you could say RT is congruent to itself. And that is the reflexive property. Anytime something is congruent or equal to itself is the reflexive property. Yeah, okay, I can see where I'm going here. So triangle QRT, so this triangle is congruent to this triangle. So I need to line this up though. So 3 goes with 2, 1 goes with 4. So Q is going to go with S. Then R is going to be T. And that leaves me with Q. And that is from the ASA property theorem. Okay. So I have 2 angles, and the side that's in between them are all congruent. So 2 angles are congruent, the side in between them. And then QR is congruent to ST, and QT is congruent to RS. That is through our CPCTC. Corresponding parts of congruent triangles are congruent, because since the triangles are congruent, both of their, if I flip this one over, both their left sides, or right sides, if I'm flipping this one over, both their right sides have to be congruent as well.